Hello everyone, my name is Aryan, and in this video, I am going to present to you Keystone, which is a GraphRAG platform that augments semantic retrieval with knowledge graph traversal, event-driven orchestration, and automated evaluation for fast citation-grounded question answering. So now the overview of the project is that Keystone is a graph platform designed to answer complex questions over a large collection of unstructured documents by combining semantic retrieval, knowledge graph traversal, and LLM-based response synthesis within an event-driven architecture. The traditional RAG systems were solely dependent on the vector similarity search, often missing the relationship that span across various documents that we have. So in Keystone, we basically have Neo4j, which is a knowledge graph kind of thing, which maintains the relationship along with the vector similarity search so that nothing useful information is getting lost while we try to retrieve the information. To improve the scalability and the responsiveness of the entire project, we have used asynchronous Kafka workers for document ingestion and evaluation. There is a line graph orchestration pipeline that coordinates the retrieval, the graph expansion, the response duration, and the citation validation. We will look more about it in the high-level design part of the video. So yeah, the core features of the project is basically the hybrid graph RAG retrieval, the knowledge graph traversal using Neo4j, semantic vector search using Qdrant, Redis backed semantic caching, LangGraph orchestration pipeline, Apache Kafka event-driven processing, automated document ingestion, and like citation validation guardrails also there. So let's have a look at the user interface. So you can see that the user interface looks something like this. Like we have the query workspace and the knowledge ingestion. We can in the knowledge ingestion we can upload the documents that we have in the query workspace. We can ask for the information and they can give us the information and also the citations that from where it has taken. So now let's have a look at the demo video for this application that we have. So we can see we have query workspace and knowledge ingestion. So basically in the knowledge ingestion, we are entering all the documents that we have along with the information that the documents carry. So basically over here we have four documents. So we will use all the four documents, and obviously these documents have certain relationship between them as well. So the aim is to show not only the semantic meaning is conserved, but the relationship between the documents is also conserved. So all the four documents I have ingested. Now in the query workspace, we will basically go and ask certain types of questions so that not only the particular answer is getting out, like we get retrieved, but the cross relationship between them is also getting shown. So we can see that I am writing the first question, and now after the first question is written, like it will take few time to think about it, and like it will provide me with the relevant answer. So over here, the sources tagged is basically the products.txt. Now I am going to ask the next question, like what is the fulfillment center? So it has been taken from orders.txt. So now I'm typing the third question. So the third question is taken from fulfillment because the main question was related to fulfillment center only. And now this question is like a cross question wherein the question is asked in such a way that it has to refer to a different kind of documents that we have to answer this particular question. So over here, it has referred to products.txt and fulfillment.txt to uh, answer the question, and it has, ensured that the relationship between the documents. Now let's talk about the high-level design and the system architecture of this project Keystone. So over here, we can see that the workflow starts when a user uploads documents or submits a query through the fast API gateway. During document ingestion, upload requests are published to Kafka, where an asynchronous ingestion worker is there, which basically chunks the document by content and extract the entities and generates this sentence embedding using sentence embedding transformer. Okay. And then this embedding is indexed in Quadrant. It is indexed in Quadrant vector database along with the Neo4 J knowledge graph, so that uh, uh, all the relationship between all the chunks that we have is also stored over there. Now, during query execution, that during the query execution phase that we saw, basically the main thing is that the API gateway first checks the Redis semantic caching, and if it is a cache hit, then it can obviously return it from here itself. And if it is a cache hit, then it has to go to the language LangGraph planner that we have, and from here we have a parallel retriever which refers to both the Quadrant vector database and Neo4j graph knowledge, and it uses things from both of them, and then uses the context fusion RRF, which is basically reciprocal rank fusion that we have, and then it uses Gemini answer generator by the all the knowledge that it has, and after that, it also have a citation validator, which basically ensures that all the answers that we have presented is from the all the citations and everything is properly mentioned and is correctly over there. So that's the main aim. So this is the entire high-level design of the entire Keystone project that we have. So basically, this is also the same retrieval pipeline that we discussed about right now. That if there is a cache hit, then it will return that response. If there is a miss, then it has to go to the graph traversal, vector search, and then land graph orchestration is there for context assembly citation collection, and then Gemini response generation is there, and then citation validation there, return the final response. Now let's talk about the architectural performance. So basically, in this application, uh, what basically the cache hit latency is 35 milliseconds. The cache miss latency is 255 milliseconds. So the latency reduction is about 86%. So I tested concurrency load on this application also with 20 uh, virtual users. And the throughput was about 7 requests per second, and the P95 latency was at around 1.25 seconds. Uh, Now let's talk about the engineering decisions that we have. So basically, it took me a quite a good time to develop this project. So everything like why did I choose this particular thing over the other alternatives that are present? I have I have documented everything in perfectly over here. Like what was the design decision? What is the rationale behind it? Like I have mentioned everything, and more or less we have discussed everything in the high level design discussion part only. But if someone is interested to know more about, they can visit my GitHub repository, and over there in this README file, they can read up more about it. So yeah, that's more or less about the project Keystone that we have. So again, Project Keystone is a GraphRAG platform which is designed to answer complex questions over large collection of unstructured documents by combining semantic retrieval, knowledge graph traversal, and LLM-based response synthesis with an event-driven architecture. So that's it for this